class this morning. We are looking at stoichiometry revision. And under that, we'll be studying that under the objectives. I'm going to define stoichiometry. We're going to learn how to write the word equations. We're going to learn how to calculate relative molecular mass, and thereafter we're going to solve some word problems. Now, stoichiometry basically is just a study or calculation of the different quantities of reactants and products in a chemical equation. And now, this stoichiometry is based on the law of conservation of mass. Now, how do we write word and chemical equation? The first one, for the formation of water, if you are asked to write the chemical equation, now you go ahead to say your hydrogen reacting with oxygen to give you water. That is chemical equation. If you're required to write the word equation, now this comes up in IGCSE. You're to write in word, but this sign is very, very essential. So you go ahead just to interpret what you have here, your hydrogen here, your oxygen here, and your water there. Let's look at another example. If you have to write a word equation for reaction of calcium carbonate with hydrochloric acid, I gave this as a task. I'm not too impressed with the responses I got. That's why I'm going back to this. So now, your calcium carbonates reacting with hydrochloric acid. Now, because you've been told to write a word equation, this is very, very important. So you put this arrow, then you list your products: calcium chloride, carbon dioxide, and water. Now, if you're required to write the chemical equation, yes, this is calcium carbonate, this is HCl, calcium chloride, CO2, and water. Now, how do we calculate R.M.M? If we were to calculate the R.M.M of CO2, you know this. Your carbon is 12, oxygen is 16. How do you go about it? You bring your carbon here, which is 12. Your 16 will come out here. This is 2. It should reflect there. Now this becomes 2 plus 32. And you have 44. The unit is very important, gram per mole. The second example, if you have to calculate the relative atomic mass of this, relative molecular mass of this, you substitute your value. This 2 is important. Your aluminum is 27. Your sulfur here, you're having 3 of it. So you put the value of sulfur, which should be 32, times 3 plus your oxygen here is 4 in 3 places. 4 times 3, that becomes 12. And the value is 16. So you put that. By the time you open your bracket and you sum it up, you're going to have 342 grams per mole. Let's look at other examples. Now, you are told that calcium carbonate decomposes when it's heated according to this equation. Now, you are told to calculate the mass of calcium oxide that is produced when this gram is heated until there is no further change, and you're given these values. So, the first thing, you write a balanced equation. So, this equation is balanced. From what we've done before, the R.M.M of CaCO3 is 100, R.M.M of CaO is 56. Now, we know the formula that number of moles is given mass divided by the relative molecular mass. Your given mass for this was 20. The R.M.M from here is 100. So that means 20 over 100. That gives you 0.2 moles. Now, number of moles, you know the number of moles. And from the formula, you know that number of moles is given mass divided by molar mass. You know the molar mass, you know the number of moles. So just make your given mass subject of the formula, and you're going to divide this by molar mass. So you multiply. Just make your given mass the subject of the formula. At the end of the day, you're going to have 0.2 times 56, and the mass is going to be 11.2 grams. So join me in class for further explanation on this.